Okay, for determining types of triangles, we have to remember the rules. So if, let's make that a little smaller. If a squared plus b squared equals c squared, right, we have a right triangle, right? And if a squared plus b squared is less than c squared, then we have an obtuse triangle. And if a squared plus b squared is greater than c squared, then we have an acute triangle. So if you're given three sides of a triangle, I don't know, maybe 5, 6, and 7. The first thing you need to do is make sure that they're in order from least to greatest, because the c is always the greatest. So in this case, the last one is the greatest. However, if the three sides were presented like this, then this would be c. So it's always best to rearrange it and put it in ascending order. I think that's makes it easier to just substitute in for a, b, and c. So in this case, we have we're trying to see a squared plus b squared, and we want to know like kind of the relationship to c squared. So I have 5 squared plus 6 squared and 7 squared, right? So 25 plus 36 and 49. 25 and 36 is 61, which is greater than 49. So 61 is greater than 49, so this is an acute triangle, right? Okay, another thing to keep in mind, remember that when you're given the three sides of a triangle, you first have to make sure it's actually a triangle. So for instance, if you got the sides like 5, 6, and 20, clearly this is not a triangle, because remember, for any triangle, the sum of any two sides has to be greater than the other side. So in this case, 5 plus 6, right, is only 11, which is not even greater than the third side. So if this were the triangle given, you would say this is not a triangle. You would not identify the triangle because it's not even a triangle. Okay, when you're given a tile pattern and asked to find the equation, typically you're going to write the equation in the form y equals mx plus b. So let's remember what the m and the b are. The b is the y-intercept, which is how many tiles are in figure 0, right? And the m, right, the m is how much each one of these is changing, right? So we're adding a certain number, right? So in this case, we're actually adding 3 to 4, adding 1, we're adding 1, we're adding 1. So the m represents the adding the 1. So to write the equation for this, first we would need to find figure 0 because it wasn't given, right? So to find figure 0, we're going to go this way and subtract 1, because if we're adding 1 to go to the right, we're going to subtract 1 to go to the left. So in figure 0, there would be 2, right? So now I know my equation, right? Because I know that b equals 2, because that's the number of tiles in figure 0, and m equals 1, because that's what I'm adding by each time. So the equation would be y equals 1x, right, plus 2. Now, normally you would not leave the 1 in front of the x as it's not needed. So the final answer would be y equals x plus 2. But you should show this work to show that you actually know, right, that the 1 here came from here, and the 2, right, came from here, right? So it's good to write y equals 1x plus 2 and then change it into y equals x plus 2. Okay, for solving equations, right, you could have any type of equation. It could have fractions, right? It could have more than one term on each side, right? So the goal is to get all our variables on one side and all the constants on the other side. So I'm going to subtract 5x here from both sides. And again, show this work. It'll reduce the number of mistakes you make, right? And then I'm going to subtract 1 from both sides. I get negative 3x equals negative 4. And then I'm going to divide both sides by negative 3. And I get x equals negative divided by negative is positive. X equals 4/3. And I'm going to leave it just like that as an improper fraction. Okay, for square roots, there's a couple things you need to be able to do. First, if I gave you a perfect square, you need to be able to simplify that. So the square root of 121 is 11. And again, this is the positive or principal square root, so you would just write 11, not plus or minus 11. Okay, the next thing you're going to need to be able to do is to simplify square roots. So you need to understand when a square root is simplified. So clearly, if it's a perfect square like this case, it's not simplified. You need to write the actual perfect square, the 11. However, it's not as simple as that. If we have something like root 32, now 32 is not a perfect square. However, it's not simplified. And the reason why it's not simplified is because there's a perfect square factor inside of the 32. So this is really the square root of 16 times the square root of 2, right? 16 times 2 is 32. So the 16 is the perfect square factor that has to get factored out. So the square root of 16 is 4 times root 2. This would be in simplified form. So the thing you need to check is whether or not the radicand, or what's underneath the radical, has a perfect square factor in it. And the way you do that, you just kind of you can look at it, but if you don't see one right offhand, you could just go through all the perfect squares, right? So you could go through 4, 9, right, 16, 25, 36, right, 49. Probably by this time you're gonna have found one. You're gonna see if any of these go into the radicand. And if they do, then you need to factor it out. So and you want to get the biggest one, of course, first. So in this case, the 16 went in. It went in 2 times, and we pulled the 16 out as the square root of 16, which is 4 root 2. Okay, and the final thing you're going to need to do is to estimate radicals, right? So let me make some space. So let's say we had root 34. So root 34, it is simplified. If it were the answer, you would leave it like that. However, if a question says estimate this number, right, the way we're going to do that is we're going to find the perfect square on both sides of 34, right? So again, if you can't remember them, just write them down. There's 4, 9, 16, 25, 36, 49, right? Okay. So to the left of 34, we have 25, and to the right of 34, we have 36, right? So the way we're going to estimate this, we know that the square root of 34 is bigger than the square root of 25, right? Because, right, the square root of 25 is just below it. So it's going to be between 5, right, and 6, right? 25 is 5 and 36 is 6. So it's 5 and some fractional part. The way you figure out the fractional part is you figure out the distance from 25 to 34. And the way you do that is you subtract 34 minus 25. And you put that over the distance from 25 to 36. And again, the way you calculate that is you subtract 36 minus 25. So the fraction becomes 5 and 34 minus 25. That's 9, right? 9. Over 36 minus 25, which is 11. And there is the estimate for the square root of 34. So if you typed the square root of 34 into your calculator and then you typed 5 and 9/11 in, you would get a pretty close estimate to that. Now, estimates for square roots are always going to be left in a mixed number because you are only really estimating the fractional part, this part here, right, for how much bigger it is than the perfect square below that. Okay, Pythagorean theorem, applying it could be many things. So we could have a map that we want to find the distance between something, 2 points, or it could be as simple as me providing you with, a right triangle, right? And maybe this is, 12, and this is 7, right? This is a right triangle. And, I say find the missing side. Now, you might have to draw this triangle onto a figure and then find the missing side, but it's all going to boil down to you finding the missing side of a right triangle. So remember the relationship between the sides of a right triangle. So we have a squared plus b squared equals c squared, and c squared is always the longest side, or the side opposite the right angle. So in this case, a could be 7 or x, it doesn't matter, right, a and b. So it's x squared plus 7 squared equals 12 squared. So we have x squared plus 49 equals 144, right? So we're going to subtract 49 from both sides. And this leaves us with x squared equals the square root, equals 95. Let me clean that up a little bit. Right, equals 144 minus 49 is 95, right? 144 minus 44 is 100, and then another 5 more is 95, right? Okay, so in this case, x would be the square root of 95, like that. And then we would make sure there's no perfect square inside of 95, which there's not. If there was, we would simplify it. Otherwise, we would leave our answer just like that. When we are simplifying expressions that have powers or exponents, we need to remember our rules for powers. So in this case, what I'm going to do to get to the next step, I'm just going to kind of go one by one here, right? So 12 over 8, that has a common factor, right? There, a 4 goes into 12 and a 4 goes into 8, right? So this becomes 3 over 2, right? Then x to the 5th in the numerator, there's no x in the denominator, so that's going to remain up there, 3x to the 5th. Now, y to the 3rd over y to the 7th, that gives me y to the 4th in the denominator. Or I could have said y to the 3rd over y to the 7th gives me y to the negative 4th in the numerator, but then I would have to move it down into the denominator as y to the 4th. And same here, there is this invisible 1 here, right? There's an invisible z to the 1st. So z to the 1st over z to the 4th, that's 1 minus 4, that's z to the negative 3 in the numerator, or z to the 3rd in the denominator. And there is your simplified version. If you did it the other way, let's say you wanted to go with the negatives, you would have the 3 halves, that remains the same. Then x to the 5th, right? And y to the 3rd over y to the 7th, that's 3 minus 7, that's y to the negative 4th. And then z to the 1st over z to the negative 4th, that's z to the negative 3rd. And then you'd have to say, okay, negatives are not, simplified. So you would have to move the y to the negative 4th to the denominator as y to the 4th, and z to the negative 3rd as z to the 3rd, right? And do it that way, right? So either do it straight or do it to the negatives. Either one is fine. You'll end up with the same result. Okay, so how do you identify rational and irrational numbers? So let's remember. So rational numbers, right? rational numbers, you can write it as a fraction, right? A over b, where b is not 0, right? So anything that can be written as a fraction is a rational number. So some characteristics of rational numbers, they either terminate, and terminate means, terminate like 3.8. It terminates, it ends, 3.8. 7, that terminates. 7.821, that terminates, right? Or it repeats, right? Repeats. So repeats would be like, 0.6666666 or 0.23232323. They repeat. And irrational are all the others, right? And typical irrational numbers, right, that everybody typically remembers, right? Pi, it's a key one because it doesn't terminate or repeat. And then any square root of a non-perfect square. So root 2, root 3, root 5, right? Any non-perfect square is irrational. Okay, so let's identify some of these using these rules, right? So let's say we had, 0.273 and the 73 repeated. This would be rational, and I'm going to write R. You would write rational, but because it repeats, right? And we could convert it to a fraction if we needed to. How about, I don't know, root, 10. Well, root 10 is not a perfect square, so that's irrational. How about 0.371? Well, 0.371, that is terminating, right? And it could also be written as a fraction, 371 over 1,000, right? So that's rational. How about 3.14? Well, 3.14 is not pi. 3.14 is 3.14. Pi doesn't terminate or repeat. So in this case, 3.14 is a rational number. If I wrote pi, right, what's pi, then you'd say that's irrational. But 3.14 is rational, same as 22/7. By definition, it's a fraction, so this is rational also. These are just estimates of pi. Don't get confused with pi and estimates of pi. Okay, let's convert some decimals into fractions. So let's say we had an easy one, right? 0.12, and I wanted to convert that to a fraction. So this would be 12, right, over 100, right? Because I need to move decimal places 2 places, right? So this is 1 is the 10th place, 2 is the 100th place, 12 over 100, and then I would have to reduce. Well, let's see. 2 goes into both. That's 6 over 50. But then 2 goes in again, right? That's 3 over 25. And that would be 0.12 converted into a fraction. Let's say we had, 0.12 repeating, right? Let's convert that into a fraction. So the way we do this is we assign, x to be 0.12, right? And then 0.12 repeating. And then we're going to multiply x by either 10, 100, 1,000, 10,000, and what we're going to multiply by is dependent on how many digits repeat. So in this case, 2 digits repeat, the 1, 2, 1, 2, 1, 2, 1, 2. So we're going to multiply by 100. If one of the digits repeated, like 0.33333, the 3 is repeating, then we would multiply by 10. So if I multiply by 100, it's going to shift the decimal 2 places, right? And I'm going to get 12.121212. Okay, so now we're going to subtract. So on this side we get 99x, and over here we get 12, because the 0.12 repeating cancels out, right? So now I divide both sides by 99, right? And I get x equals 12/99. And that is the fraction that represents 0.12 repeating. If you type that into your calculator, you would get 0.12121212. However, this is not reduced, right? Because quickly you see that they both have a common factor of 3, right? 3 goes into them. So you always have to reduce your fractions. So this becomes x equals 12 divided by 3 is 4. 99 divided by 3 is 33. So the estimate for 0.12 repeating would be 4/33. you would not box x equals 4/33 because you just used x to figure out what the fraction 4.12 repeating is. So do not box x equals 4/33, box 4/33. Okay, let's draw a quick sphere here, right? And you could draw it better, I'm sure, on regular paper, not an iPad. Okay, so let's say we need to calculate the volume of the sphere, volume. Okay, so you need some information. Let's say I give you the diameter as 6 inches, the diameter of the sphere. So first you need to write the formula for the volume of the sphere, which is 4/3 pi r cubed. And unless the question says use 3.14 for pi or use whatever for pi, we're going to leave it in terms of pi. So I get V equals 4/3 pi, but then I need r. I only have d, so r, the radius, is 1/2 the diameter, right? So the radius equals 1/2 of 6 inches. So the radius equals 3 inches. So now I can use 3 inches here. So 3 inches cubed, right? So the volume equals 4/3 pi times 3 cubed is not 9, right? It's 3 times 3 times 3, which is 27, right? Inches cubed. And then I need to multiply 27 times 4/3. So 27 divided by 3 is 9 times 4 is 36, right? Pi inches cubed. And that would be appropriate work to show the volume of the sphere given a diameter of 6 inches. Okay, for volume and surface area of prisms and cylinders. So prisms and cylinders are done the same way. So whether we were working with a cylinder or whether we were working with, let me draw it better, right? If we were working with a rectangular prism, right? You get the idea, right? Okay. Right. Okay, either one. They both work the same way. So I'm just going to use a cylinder, but again, you should be able to apply this to any prism, whether it's rectangular, triangular, they all work the same way. That's the joy of learning one generic formula. So the formula for the volume, right? The volume is the area of the base times the height, right? So we need the area of the base first. So in this case, let me make sure you can read that. I gave the radius as 7, right? So in this case, the base area, it's a circle, right? So it's pi r squared. So the area of the base is pi times 7 squared. So the base area is 49 pi. So we have the base area. And we know the height. So now we know the volume is 49 pi times 10, which is the height. So the volume is 490 pi units cubed, right, for volume. Okay, so that's the volume. So the surface area, the formula for surface area, again for any prism or cylinder, right, the surface area is, we have the top, right, the top and the bottom base, so that's 2 base areas, plus the perimeter, right, the perimeter of the base, that's this, the perimeter of the base, which for a circle is really a circumference, but we're going to call it the perimeter, times the height, right, the height. So we already calculated the base area, so we have that, but we did not yet calculate the perimeter, so I'm going to calculate the perimeter down here. So the perimeter in this case, it's a circle, and the circumference of a circle is 2 pi r, right? So the perimeter is 2 pi times 7, perimeter equals 14 pi. So now we calculated the perimeter, and we have everything we need for the surface area. So now I can substitute in 2 times the base area we calculated as 49 pi, right? 49 pi. And the perimeter we just calculated as 14 pi times the height, which is 10, right? So let's simplify a little. The surface area, 2 times 49 is 98 pi, plus 14 times 10 is 140 pi. And then we just need to add these, right? 140 pi plus 98 pi. So the surface area comes out to be 238 pi units squared. Remember, surface area is squared, volume is cubed. Okay, the volume for cones and pyramids, the formula is the same, so I'm going to do a cone. The pyramid would be the same. So the volume for a pyramid or a cone is 1/3 the base area times the height. So the first thing we need to do is determine the area of the base. So in this case, the area of the base is a circle. So the area of a circle is pi r squared. Now, if we were dealing with a rectangular prism, right, the area of the base would be length times width, and you would use that calculation. So here, to calculate the area of the base, we do pi times r, which is 7 squared, and we get 49 pi units squared, right? There's the base area. And we know the height, so now we could substitute in. So we get volume equals 1/3 the base area, 49 pi, times the height, which is 10, right? So we get the volume to be 1/3, 49 thirds pi times 10, which comes out to not a great number, but not so terrible, right? 490 over 3 pi units cubed. And I would just leave it exactly like that. 490 over 3. It's not a beautiful number, but it's an improper fraction, which is fine. For solving problems with ratios and proportions, we're typically given a situation that we need to set up a proportion to help us find the solution. So in this question, let's hypothetically say that I have over here in this bucket, right, that I have 3 gallons of gasoline. And with those 3 gallons of gasoline, I can drive my car for 36 miles. And the question may ask, if I want to drive my car for 54 miles, right, how much gasoline am I going to need to get? So we can set up a proportion for this. We can say that, with 3 gallons of gas, I can drive 36 miles. And the question is, to drive 54 miles, how many gallons of gas? So this simplifies, right, down to 3 over 36 equals what over 54? And the first fraction, before I start doing anything, whether I'm going to cross multiply or whether I'm going to see what happens in the numerator or denominator, I should simplify my fraction. So 3/36 simplifies to 1 over 12, right? Because 3 goes into 36 12 times. So now I have a couple choices. So I could use different techniques to do this. One common one is to cross multiply. So In this case, I get 12 times x equals 1 times 54. So 12x equals 54. I could divide both sides by 12, right? And x would equal, now this goes in, 12 goes into 54. 4 is 48 and another 6. So that's 4 and 6/12, right? 4 and 6/12. But clearly 6/12 is a half. Now, before you box that answer, remember this is a word problem. They're asking how many gallons of gas I would need, and the answer would be 4 1/2 gallons. There was no x in the question, so there should be no x in the answer. So in this video, we've covered all of the topics on the test. Clearly, you should be studying more difficult problems than the ones I gave as examples, but this should be a good foundation for the upcoming test. I highly recommend you go through the homework problems on the review sheet and watch videos for any of those homework problems that you were unable to do. In any case, good luck.